So now I'm just making the hub snout. So this is the piece of the output gear that's going to interface with the unit bearing and apply the drive torque to the wheel. And it's just a series of simple bosses and clearances for those bearings. And then I need to do the same thing on the tall knuckle to make bearing clearances for the input gear and the idler gears. Right now I'm just fixing some screws to make sure that they all match up properly. I realized I missed some screws here that I need to put on the outer shell. And then I had this strange offset there where these two holes weren't matching up, but I ended up figuring out why. Checking my thread depth. This is super critical in tapping design. So when you're designing threaded holes, a good rule of thumb is you don't want to go too deep on the threads. The rule of thumb that I like to use is your thread depth should be no greater than 4 times the diameter of the screw. So for example, if you have a 1/4 inch bolt with a 1/4-20 thread, your thread depth should be no greater than 1 inch. That's just a rule of thumb that a mechanical engineer taught me one time, and it tracks because the default thread depths in SolidWorks Hole Wizard are about that. So I usually like to keep those default whenever I can. So now I'm realizing I need some clearance on these teeth in order to clear some of the features inside the portal box. So I'm making these resolved cuts here where I'm basically cutting a chamfer around the entire radius of the part, or the entire perimeter of the part. It's just a lot easier than making 40 discrete chamfer features. Just make one cut. This feature that you see here is the O-ring groove. So there's a lot of rules when it comes to designing O-ring grooves. I always defer to the Parker O-ring manual. So they have the biggest catalog of O-rings available in metric and imperial. And they also have groove dimensions in there. So like there's a lot of things that you want to do with an O-ring groove. Like for example, you want the bottom of the channel to be radiused. You want the outside of the channel to be chamfered, and you want a little bit of a taper in there as well so you get good engagement. So like if you have a 16th inch O-ring diameter, you want the width of that groove to be 120% of the diameter, and you want the depth of that groove to be 80% of the O-ring diameter. Those are good rules of thumb.